Today I have the pleasure of chatting with a husband and wife team who, between them, made an important contribution to the creation of my favourite computer, the Amiga, a computer I don't think either of you expected to be talking about 37 years later. No. Dr. Tim King, Jessica King, welcome. Thank you for inviting us into your beautiful home today in the quite frankly stunning Welsh landscape. And I'd like to start at a time before the Amiga, though, before even the Motorola 68000 processor it used was released, and hear about the events that led up to both of you being involved with the Los Gatos Amiga team. So can you share with us how you came to be working in the field of computers in the late 1970s?
Well, I've always been interested in computers. My school was given a computer that none of the teachers knew how to work. So I just was intrigued and taught myself and wrote a program. Was playing tic-tac-toe with things with a little rotating ball that tapped out different letters and so on and so forth. And so I taught myself to program. That was about 1969, I think. And then I went up to Cambridge and did maths for 2 years, which was a disaster because I'm not very good at maths. And then swapped in the third year to computer science. I was one of the first students to do a computer science undergraduate course. And I was taught by people like Roger Needham and David Wheeler, who are a very underestimated computer scientist. And then I went on to do a PhD in computer science, where I wrote a database. And that finished in 1970. Well, it started in 76, finished in 79.
Yeah. This is one of the first relational
database systems. And then I did 2 years postdoctoral work working in the Department of Anthropology, helping them use my database in order to store lots of old documents about a place in Essex called Earl's Colne, and Jessica was working on that project as well, although we were met much earlier than that. And as part of that, I started to utilise the Tripos operating system, which was the sort of local Cambridge operating system, on a Data General Nova computer, which we used for data entry and various other things. So I was very familiar with the whole of Tripos and.
So Tripos itself, why did that come about? Because there were other operating systems at the time.
Martin Richards, who was the inventor of BCPL, was very keen on portable programs. That was still is his whole thing. So he liked the fact you could write a program in BCPL and it could run on a DEC 10 or an IBM mainframe or BDP 11 or anything like that. He thought it would be a neat idea to extend that from having a program which was run anywhere, to having an operating system that would run anywhere. And because it was Martin Richards, the entire operating system was written in BCPL. Not the whole operating system, there was a kernel underneath that was written in assembler, but the vast majority of it was all written in BCPL. Much like the Unix operating system is mostly written in C.
And you mentioned the PDP 11, so what was that like to work with as a computer?
Well, Jekyll used to use it.
Yes. Oh gosh, I remember, yes, you had to flip all these little things and we did set it up, and there was it was, if you think back to the days of the early Doctor Who with the tapes that went round, it was that sort of computer, wasn't it?
So it was like a big cabinet.
A big cabinet.
Lots of purple buttons on it and so on and so forth. And you literally couldn't just turn it on. You had to set in one address, press load, set it to another address, press load again, and then set another address and then press run. And it's one of Jessica's favourite put-downs to young spotty kids who who think that they know much more about computers than she does, because she has the immortal line, "I bet you don't know the boot sequence of a PDP-11."
I don't know. We have one in the museum, and I'm like looking at it thinking I'd love to get that up and working, and now I know who I need to come and talk to, which switches do what. And you were talking about portable. So what does it mean to be a portable application or operating system?
Well, it's part of the whole philosophy behind Java, in fact, much later on. It was the idea that you write once, use anywhere. And so the whole Java concept is that you write a program and it runs on a PC, but it also runs on a mobile phone, and it runs on lots of other things, including a sort of chip inside a car and various other things. Now, for various reasons, that never really came about. I mean, the Java inside Android, for example, is mostly the same as the Java you run in a laptop, but it's not, because the graphics are all different. But in the same way, BCPL much before that had the idea that rather than have to write a program all over again, which is in many ways something we've come round again to, because these days you have to write an app, you have to do an iOS one, you have to do an Android one, but back in the day we thought it was a good idea to write one program once and then have it run everywhere. But of course you didn't have the sophisticated graphics and all that sort of stuff, so as long as just printing out on the screen or something, it was quite easy to write a program that ran on different computers.
And were they creating Tripos as a sort of academic exercise, or was there any kind of goal to commercialise it?
There was no goal to commercialise it. Nothing in Cambridge has done with the goal to commercialise it. It was purely as an academic exercise, and also a way of actually using some of this hardware that they were buying in that didn't have a very good operating system. Cambridge has had a long history of thinking that it can write a better operating system than computer manufacturers do. So, for example, when I was working there, we had an IBM mainframe, but we didn't run IBM software on it. We ran something called Phoenix, which was written by the computing service, and was a front end to the basic IBM system, but completely different.
And you mentioned that obviously you didn't have any influence over it. So when you started using Tripos, was there anything missing that you felt could have been included?
Oh yes, I mean, it was very much the Cambridge Labs standard operating system, because we had the hardware, it would just run Tripos and everybody built it the same. And what was nice was if it didn't have a program to do something with it, you just wrote it, because we could all write in BCPL, and you just wrote a BCPL program, and hey presto, you added the functionality to it. So from that way, it sort of grew semi-organically. It wasn't like there was a huge design. The three guys running it on were doing the filing system, the console system, and something else I forget now, maybe the kernel. Those elements came together, and then all the extra commands and so on and so forth were just useful things that people wrote. I mean, I wrote a word processor that was quite useful, that just goes into the pot of what people made, basically.
And you mentioned the kernel there. Did it have a name in Tripos?
It was just called kernel, yes.
It was called kernel. And if I understand it correctly, that did a thing called preemptive multitasking.
Well, that was a very basic bit of Tripos that couldn't be done in BCPL. So it basically said, I'm getting an interrupt, stop whatever's happening, and on this interrupt, do something. And the whole concept of Tripos it's called packet passing. You're not really passing any packets, you're not copying anything, you're just giving pointers to shared memory. So it only works in a shared memory space. But say you're a filing system, you say, I want to receive some data, so I send a packet to the device driver, which is also written in assembler, and now I wait for the packet to be returned. And something else can do somebody else while I'm waiting for this packet to be returned. The device driver, meanwhile, accepts the packet, says, go and fetch this data off disk. The data later arrives. The device driver goes, oh, thank you, I've had an interrupt to say the data's back. I'm going to send you your packet back with the data inside it. So as far as the filing system is concerned, it says, send a packet, wait for it to come back, it's got the answer. And the whole system works like that. So if you want to send something to the console, send a packet, and with a C in it, and then wait until it sends it back saying, I've written it. Or you want to get a keyboard the other way around, send a packet to the keyboard driver, when somebody types something, I'll get it back. And that's just it, it's just called packet passing. And it was how you did operating systems in the 1970s, or 1980s. And so this is all written in kernel for the different architectures that were involved. But that was quite a small piece of work compared to doing a whole operating system.
And that allowed, so the preemptive part is around the kernel sort of scheduling and keep in control of what's processing?
Yeah, basically, you have this queue of what's the most important thing to do next. And if they're waiting for a packet, then you don't give them any work. And if they've got some work to do, you give them the work to do. And it's possible for one process to hog everything, because if you've got one process and it's just sitting there counting up 1, 2, 3, or going in a loop or something, then nobody with a lower process will ever get a look in, unless that does an explicit yield which says, I'm going to stop for a bit and let somebody else have a go. But in reality, that very rarely happens.
So the preemptive part was about letting everything have a share?
It was more about when something important happened, like some data arrived at disk, then let the filing system get on with it, because the filing system's got a more important priority than me doing something here, because after all, it's working for me to bring the data that I requested.
So the thing you're running can't hog the computer, it has to...
But let the filing system get on with it and so on and so forth.
Okay. And that was obviously quite different from other operating systems at the
Well,
time.
yeah, I mean, if you had something like DOS, it was a question of go and write something to disk and I'll twiddle my fingers until it's finished doing it. No.
So there's no memory management as such?
Because the chips didn't have it.
Right. So if they'd have had it, you would have used it, do you think?
No, Tripos couldn't use it. I mean, that's not quite true. The PDP-11 had memory management. Mm-hmm. But no, this was a design for a very simple, flat address space. Such was seen in a lot of the processors at the time. The whole concept of memory management, virtual memory, paging memory, they're all much more sophisticated techniques that are obviously used today. But at the time, no, this was a flat memory space. Everything was in memory. If you didn't have enough memory, it stopped working.
That gave a speed advantage, though, I presume.
Well, it was fast, and if you had lots of memory, it worked fine. A lot of these machines were limited on memory, so that was a constraint. But it was simple, and it didn't require, more importantly, it didn't require hardware costing hundreds of thousands of pounds, which is what the hardware at the time cost.
Now, I understand another concept that Tripos was using, a fairly new thing at the time, was shared libraries.
Yeah, that was one of the main features that distinguish it from Unix. Unix, everything's written in C, but every time you write ls, which is a command in C to list your files, or to run a compiler or whatever you want to do, it would have to load in all of the C libraries. Because this program was written in C, it was bound to all the C libraries, and it would all bring them in. Later on, this evolved, and it could remotely link to a shared library, and so it had this same thing that Tripos had. Tripos from the beginning said, well, we've got the BCPL library in memory because it's all written in BCPL, so as long as you're writing a program in BCPL, the library's all there anyway, and so that meant that commands like ls and so on and so forth were like 400 bytes, they were tiny, because all they were doing was making calls into the operating system layer, which was already in BCPL and was already in memory.
So that allows swapping out newer versions?
Well, it really means just programs are smaller. You don't have great big huge programs which have to be loaded into disk from a floppy disk, which takes a lot of time.
So we're obviously at Cambridge University at that time, and then you've got your doctorate, and then you've decided to leave and...
Well, I stayed on for 2 years working with this anthropology department in this project, and then in 1981 I left. Because a researcher job was only ever a 2-year contract. It's a real job. And I went to join an old friend of mine, in fact, Professor John Fitch, who had gone down to Bath University, and he set up a Department of Computing. Well, actually, it was in mathematics, but it was in Bath University. And I went down there and joined him as a lecturer, teaching computer science.
So you've left Cambridge to go to Bath University. Jessica, where were you at that time?
I went with him because we were married. I can't remember the exact timing, but after that I was doing a lot of freelance work from home, and then I joined this very small company called Metacomco because they needed somebody to help with their documentation, and I was quite rare, I suppose, in those days that I actually had used computers. I did know about producing documentation and manuals and things like that from the previous job at Cambridge, and so I went to work for them part-time. And that was really the start of our link to Metacomco, which...
Yeah.
So you've effectively got your foot in the door at Metacomco, and you've got this skill where you can take that technical data and then translate it into stuff that, dare I say normal people, but that is presented in a form that other people can consume.
Yes, assuming nothing, yes.
So what year are we in now when we've moved to...
Well, I moved to Bath in 81, and I got some research grant money to work on databases again. But one of the things I needed in order to do this work was a computer. And there was a very enterprising department of electrical engineering there, and they had already embarked upon using this new chip called the 68000, and they built a computer based on it with these great big huge boards. And there was like a board like this big by that big, which was 256k of RAM, another board like this which had our 68000 chip in it, and they slotted into this rack. And they made me this computer, which was about 6 foot tall. It had a 40 megabit hard disk in the bottom, which was about 1 meter by half a meter by 30 centimeters big, and sounded like an aircraft taking off when you turned it on. And I needed an operating system for it, so some friends of mine back in Cambridge had already done a kernel for the 68000. It was all the up-and-coming chip at the time, so I got hold of that, put that onto my computer, made it work, and started tinkering with it a lot to try and really improve it to make a very good 68000 Tripos experience.
So with the 68000, obviously, there's a lot of computer manufacturers sort of selecting it.
No, this is way before that.
Way before that,
Yeah.
Okay. So you've got existing processors like the Z80, the PDP-11 and all these other things.
But then none of them could have the memory. See, the whole thing about the 68000 is that you started off with 256k of memory, not 32k.
So that was your starting point.
That's your starting point. And then you could have a 512 meg, or even, it got very expensive to go beyond those in those days. But that sort of memory gave you a huge luxury.
So the limit on the memory was more about what people could afford, not what the processor could go up to 8 megs or something like that, wasn't it? Yeah.
So that's why the 68000 was such a huge leap forward. It was a 32-bit address, but 24-bit to begin with.
Was there any other competitors at that time?
No. I mean, the nearest competitor was an IBM mainframe.
Right. So Motorola brought out the 68000. Everybody's looking at it thinking, wow, we need to get our hands on one of those.
It was very innovative. A bit later, National Semiconductor came out with a similar chip, or spec chip, but I can't remember its name now. And they were used in high-end workstations like Sun workstations and so on and so forth. And often ran Unix. It was seen as a high-end processor for, and in the day, what they called workstations, which essentially meant something running CAD software and so on and so forth. A huge, great big screen like this, and costing several £1,000s. So I was there at the very early stage of that, and I got very engrossed into it, and I taught people about the 68000. I wrote a book about how to program the 68000 and so on and so forth. Then in about 83, I realized that in particular Apple had started to use the 68000 as well. Then the early Mac came out in 83, I think. And then it became apparent that much cheaper manufacturers were looking at the 68000 because the 68000 by that time had dropped in price. It was going to become the next thing after the ZX80s and all the rest of it. It was quite apparent.
So you're at Bath University. You've got this new 68000 machine created for you. At that point, your students that are learning from you and then going off into the big wide world, you notice that there was something...
They were earning more than I was.
Right.
So I decided it was time to leave academic life. It was also, you had to stay 3 years before you achieved, what was the word? Where you couldn't get fired?
Fellowship?
No. Tenure. Thank you. And so I waited my 3 years, waited to get tenure, and then they said, we're abolishing tenure. So I thought, well, one of the big advantages of being an academic is it's a job for life, but it obviously isn't, so I'll go and join the real world and see what happens. So I'm going to work for Metacomco.
Now you say that like it was a natural step. Did Metacomco know that you wanted to move? Obviously, you've got your wife embedded in there. There's obviously some conversations
and
going on.
I knew the guys and so on and so forth. So it was a very natural step.
So they were eager to
invite
you.
I mean, I should have asked for more money in retrospect.
And it's not just you going into Metacomco. You're bringing with you.
No, that was just me.
Well, I was going to say you're bringing with you a version of Tripos.
Oh, yes, yes.
Had you completed the port of Tripos at that point?
Well, how much do you ever complete an ongoing operating system? There's always tweaks and things you're adding, but I had a perfectly working version.
So that was with a kernel and the operating system?
Yeah, and it was at the stage where I could recreate a copy of the operating system on a computer, compiling itself on its own on its own system, basically. But of course, when I went to Metacomco, one of the problems was I couldn't bring this great big, huge, massive, great computer from the university, because that belonged to the university. So I had to try and, first job was to port Tripos to another computer. And that's where this company in Reno, Nevada, called Sage Computers came in. They changed their name later to Stride. And they had a computer called a Sage 2, or was it a Sage 4? I can't remember. But anyway, it was a box about this big, by that big, and it had a 40 megabyte hard drive into it. And it wasn't expensive in those days, like it was probably about £2,500, but in the nature of things, that wasn't that expensive. And that had a 68,000 chip in it, and it ran a very weird version of P system, which is an interpretive Pascal system that was useful for teaching. And so I put Tripos onto that, which didn't take very long because I had the knack of putting it on the other one. And then that became the basic workhorse for Metacomco. And that's the computers that we used inside Metacomco for developing compilers and all the other things that Metacomco did.
So at that point, you've selected a computer. So I'm guessing was one of the first computers to use a 68,000 in a commercial setting. So this is before Apple or Atari or anybody else had managed to get one out on the street.
Not quite Apple. I think the early Macintosh is probably out there, but the Mac had its own closed operating system and only had 128K in floppy disks and didn't have the hard disk and just wasn't usable for development work.
But here you've got a 68,000 base computer with, looking at the Sage 4 spec, had a meg of RAM, the hard disk, and a 5¼ inch floppy. So you've got
all I wanted.
all you wanted there in something that didn't take up a whole room and you could put in the boot of your car.
Yes, absolutely.
So you had those at Metacomco.
And then we also found that, and because we were friends with the people at Inmos making the Transputer, we started providing these things to Inmos. So what a lot of people don't know is that a lot of the Transputer design was actually done on these Sage 4 computers running Tripos.
So we will hopefully talk about the Transputer a bit later, but even at that early stage, that's a concept that's going on somewhere.
There's all the people in Bristol, basically, because Metacomco is in Bristol, Inmos are in Bristol. And in those days, there weren't many other tech companies in Bristol.
So way before I ever heard about it, the Transputer in the magazines, etc., this was all going on.
Yeah.
So at the point, you're at Metacomco, you've got a working version of Tripos on it, and Metacomco are creating other software with it as well?
Well, yes, I mean, the main thing Metacomco were doing at that point were creating languages. They already had a BCPL interpreter, which they'd sold to Digital Research, and it was a basic interpreter written in BCPL, and that was their main breadwinner for some time. It ran on DOS. So we started producing other languages from scratch, which is a hugely expensive enterprise, to be honest. But we had the BCPL compiler, and then we worked on a Fortran compiler and a Pascal compiler. The C we brought in from Lattice. It was a company called Lattice, they had the C compiler. So it was a range of languages and their associated libraries that all had to be documented. And that was what they sold. They sold packs of software, but it wasn't games. It was underlying programs, compilers that allowed people to go and write games.
So at this point, though, Tripos is basically a tool for your company that you're both in to create other software. At what point did somebody realise that what you had as the operating system was a product in itself?
No, I think we always knew it was potentially a product. It's just that we needed to find somebody who needed to have a computer with the 68,000 that they hadn't already set their heart on the operating system. So
ruled out Apple.
Ruled out Apple.
Right.
We thought we had a chance with Atari, but in fact, they stuck with their original choice of a sort of DOS-based system with rather...
I think called TOS with Gem on top or something.
It was called TOS because it was Tramiel's operating system rather than disk operating system. And then some sort of windowing system on top. It was never very, very interesting.
So who would have been knocking on those doors? Would that have been yourself or somebody else?
No, I don't do sales. We had a chap working for us. He was extremely good at knocking on doors, but very bad at following up. But he was brilliant at knocking on doors, and he had a very thick skin, so when people said go away, he didn't. And he had discovered that this secretive company in California, and when he was out in California, it was very hard for us based in Bristol to afford to send somebody out to California.
So he's out in California, knocking on doors?
Yeah, I mean, he wasn't living out there, but we had to send him out there and fly him out there. It was hugely expensive, and no guarantee of payback. So I know he went out to Reno and he tried to persuade Sage Computers that they should include Tripos with the computers they were making, but they weren't having anything of it. And he tried various other places. And then he found this secretive, basically, company called Amiga. And he tried knocking on their door, and he got a slightly more receptive answer on that, because we now know they were having problems with the people that they'd contracted to produce an operating system for them.
So the history books tell me that obviously they were designing the hardware, and they also had a specification they'd created for their own operating system called Chaos. They weren't going to create that themselves then. They'd already outsourced that work, but unbeknownst to you at the time, they were having problems.
It wasn't going well.
It wasn't going well.
But it wasn't going at all, as we found out later.
So at this point then, your salesman's got a lead. Yeah. You're being seen as an insurance policy.
Yeah, definitely an insurance policy.
Against them not getting their operating system, because they've got this fantastic new machine that they need to get to market. Yeah. How's that now going to progress?
I don't think it was him. I think it was probably my boss. And I think he and I went out together. I can't remember. But basically we got a $30,000 contract to port Tripos to an experimental Amiga. And they gave me, I think it was Amiga number 3, well, it wouldn't be recognised an Amiga because it was a big metal box. And it had some of the chips, which in fact, when I got it home, they'd fallen out and I had to stick them back in again. And they sprayed it in this bright orange foam. And then I had to buy an airline ticket for it, so it sat next to me on the flight going home. And in fact, this was quite common. When they went out to CES, they'd already done the same trick. And
they called it Mr. Pillow.
Joe Pillow. Joe Pillow was the name on the airline ticket they had to put in.
So what was the name on your airline ticket?
No, it was just, I can't remember. I really can't remember. Yeah, I didn't use Joe Pillow. So yes, so they wouldn't let it go in the hold. It was too big to go in hand luggage. So I took this home with the brief to put Tripos onto the Amiga.
So it's still not a done deal, it's just a one-off thing just to get the operating system on it?
It was just a proof of concept, right. And they paid $30,000 to see if it could be done. Right. I took it home, took it back to my house in Frome in Somerset, and I worked very hard at getting it ported. I was up until 2 o'clock in the morning and waking up until 6 o'clock. And Jessica was feeding me meals in the middle of the night and things like this. So basically I get it going. A lot of difficulty with getting the letters on the screen. I end up phoning the guy in California, which you recall was very expensive back then. And of course I have to phone him at 7 o'clock at night and get him when he's up. And we discuss why it isn't working. And he says, well, what colour have you chosen? And I've said, well, I don't know, I haven't chosen any colour. I didn't even realise it was a colour display. I've got it plugged into a green and white display. And he goes, I may have made it so that the default colours aren't actually visible on a monochrome display, in the sense they were all the same intensity, but different hues. And then he said, go and turn all the lights off, and I did, and I could just see this faint writing. So it had been working all along, but I just couldn't see it.
I'm guessing that's because you're working on things like the Sage, with a monochrome screen. So all the computers up to that point have pretty much been monochrome. Even the latest Apple with
no colour, no graphics, nothing.
So here you have a machine, this new custom machine. You're not quite sure of the specs, and it's got this massive 4096 colour palette, and they've set it for I believe to make it look good on a typical TV type.
Well, no, this early stuff, everybody just plugged it into a Sony monitor, and they naturally assumed I had a £200-300 Sony colour monitor, which I didn't. But anyway, after about 3 weeks or so, maybe a month in the end, I arranged to fly back to them, and I had a few questions outstanding, but I couldn't make them. But mainly I wanted to show what I'd done, because I'm sort of a long way to completing the task of porting Tripos to the Amiga. So I got there, and I was kept waiting in the morning, nearly all morning. Bob Pariseau, who was head of software engineering, was quite rightly protective of his people and said, look, I know you've got a lot of questions, but I can't afford a lot of time. And then these guys can make time for you. And eventually, by about lunchtime, these guys made time for me, and I came in. And they brought out an Amiga. It was actually more of a newer one, to be honest, because they'd moved on at that point. And so I was able to stick a floppy disk in, it booted up, and I could show it booting, and I could show it Windows moving around, and I could show it editing and compiling programs all at the same time and doing all these sort of things. And I got really into this sort of demonstration. And after, I don't know, half an hour or something, I said, well, that's about as far as I've got. And I sort of turned around, and there was the entire company of Amiga behind me. And they'd all been going, hey, come and see this mad guy from England. He's managed to make our box work. And they all burst into applause. And that's when I knew I got the job.
So at that point, it's probably best you didn't know that you had this massive audience.
I'd been very nervous otherwise.
And it all worked well?
It worked seamlessly.
So even though they've done new hardware revisions,
No demonstration effect, fortunately.
So obviously you've ported Tripos, or at least to get it to a point where it's demonstratable. Now, we talked earlier about kernels, and so you didn't use Tripos's own kernel.
No, but the whole part of how I was able to do it so quickly was that Carl Sathenrath had written exec, and if you looked at the Tripos kernel and you looked at exec, there was absolutely the same. It was a memory, it was a shared memory message passing system with the exec and the device drivers, just like Tripos kernel, because that's the way you did it in those days. So it was a seamless fit. I mean, absolutely, completely seamless. All I had to do was change BCBL pointers into byte pointers, and that was it.
So that decision, was that yours?
Oh yes, it was my decision. But that's one of the reasons why I knew, when we even offered to do the job, it was going to be a doddle, because of what Carl had already done.
Right, so you'd already laid that foundation.
Yeah. And I'd seen the specs of what he'd done, and I thought, well, that's totally recognisable to me. I understand that totally.
So at this point, you've got your round of applause. You know you've got the job. Well, it's not in the bag yet. The contract's not signed.
And very much so, because there were a lot of people in Amiga who, quite understandably, were very upset that their chaos system that they designed wasn't going to happen.
In terms of this insurance policy, was this sort of like the Amiga team doing this, or was this Commodore making sure?
I don't actually know, but I think when I joined, Commodore had just come on board. I mean, literally a month before. Commodore didn't really know what they'd bought. They'd put in a manager. I think Rick Geiger was brought in by them as a manager, but I can't quite remember. I think Bob Pariseau was quite new too. And anyway, it came down to the senior management saying, look, it's a pragmatic decision. We either go with this operating system which works, or we wait another year or possibly longer for the thing that you've designed, which may or may not turn up.
So that would have they had this amazing hardware, and that would have meant more and more competitors.
Well, I think also there was quite a strong feeling that Commodore wouldn't have bankrolled them any further. So you wouldn't have seen an Amiga, I don't think.
So really, going back to my introduction, if you hadn't have come along with Tripos, we may not have even seen an Amiga.
I think I was possibly the cavalry here coming over the hill.
So at this point, we've got a demonstrated version. At what point do they say, actually, let's forget Chaos and go with Tripos?
I think it was that afternoon or the next day. It was a very quick decision. I didn't go back to England. In fact, I didn't go back to England for about 6 or 8 months after that, because I'd rented a car to go down there, and then I did this deal with them, and they said, yeah, and I got the details of the contract, which were very important to me. 2 bits that were very important. One is I could always fly business class, and B, that Jessica would come out and do the documentation, and we'd work together. And we had a few other things sorted out. They didn't have any room in their offices for about 3 more people, because we brought 2 or 3 other people out with us as well. So we all worked from a hotel suite in Los Gatos. And we had to get all this stuff sorted out. And then I phoned up Jessica and said, you're coming out to California.
How did that, to get that phone call to say you're coming out for what? I'm guessing what was going to be weeks or months?
Tim had only just really got out there, and I thought, oh, well, he's not here. I'll take the cat and I'll go and see my parents. I haven't seen them for ages because we've been working hard. And I just got up there. It was like a Saturday, I think, Saturday afternoon, and Tim says, you've got to come now, and you've got to bring everything. I said, how? But somehow I managed it. I got back down to Metacomco with the cat. Cat got lost in this empty building. Now it was Sunday morning, that's right, Sunday morning. I had the whole empty building.
So the cat got out of the cat basket?
Oh, yes. I found it later in the in the executive washroom. Yeah. I set up every single computer I could find.
All of these
sages.
So all these sages, so you powered them all up.
So I was sort of doing parallel whatever, and I had all these...
Because you're making lots of copies of all the sources of Tripos or rest of it.
Copy everything, and you wanted several copies of everything.
Well, there was no internet, remember, so the only way you could get the sources out to California was to put them on floppies and take them in an airplane.
So yes, got everything together, got the cat to the cattery, got on a plane at Heathrow, where luckily I had a very good friend who worked for Pan Am. So not only did I get on the flight, I got upgraded too.
It was in those days that if you had a friend at the airport, you just silently handed over your back of the bus ticket, and she silently gave you a business class boarding pass. They'd, obviously nowadays it never happened because it's all done on points you've had and so on and so forth. In those days, if you had a friend there, it helped a lot.
Well, Pan Am is no more anymore.
Pan Am sadly is no more.
Probably why, yes.
So you've got, a suitcase full of floppy
Suitcase
disks.
of floppy disks, everything there, all the bits and bobs, and flew out. And that was it, really. It was
I picked
running,
her up from San Francisco airport. They'd installed these Sun workstations in this hotel suite. It was quite a big hotel suite. But there were 3 of us working. The other guy came out much later. And you say we hit the ground running.
So most of the Amiga development work was being done on Sun?
Yeah, it all was, yeah, every single bit. And so I worked in the same system, basically, and put all the Tripos sources in the same repository and all that sort of stuff. And then we worked, in fact, we were out there for about 6 months, weren't we?
On and off.
No, I think the first bit was...
It was 6 weeks, or more like 2 months, maybe. We were there continuously, and then it was...
Then I had to go back, and
important.
I took the hire car back, and it was a brand new hire car, so it didn't have any numplates on it. Quite common in America that, before it's properly registered, you can drive it without any numplates. And we drove it back, and I handed my papers in, and the guys behind the counter went, "My God, are we happy to see you?" And we said, "Why?" He said, "Well, you've taken this car, and originally it was for like a 2-day rental." I said, "Oh, yes, so it was." He says, "And we've been trying to find it, but we can't because it hasn't got any number plates on it." We thought it would be in like downtown Texas by now. No, I brought it back. Right.
You've got this hotel room, you've got multiple people coming and going, you've got all your Sun workstations set up. so there's not many places to get some time to yourself. Jessica, I think you've got a story here.
Yes, it's a we had one short workstation for a number of people. So not everybody could work at the same time. And being probably the most junior person there, but I was the one who was kicked off first. So I was thinking, well, where can I go? We were in a hotel suite, so there's these computers. And I thought, I know, I'll go and have a nice long bath. So I went into the bathroom, which is just off. And it's a fabulous bathroom, and with jacuzzi, which I hadn't come across before. And I thought, I'll put some bubble bath in. Bad move. Suddenly the bubbles came up, and the foam went over the top. I thought, gosh. And it went down onto the floor, and it went towards the door, and I thought, oh no.
So you've switched it off at this point, or is it still going? Or?
I'd switched it off, yes, and I'd put towels down, and they were getting help. As the foam went underneath the door and towards the computers, oh gosh, it was the most embarrassing moment of my life, I think.
I look back because it was foam advancing across the carpet.
Squeaks from the bathroom.
But disaster averted.
Oh, yes. The computers were all right.
But we were working ludicrously long hours, and I mean, we used to finish work out in California even at about 10 o'clock. And most Californians eat dinner very early, about 5 o'clock or 6 o'clock. And the restaurants were all shut by 9 anyway. So we used to go back to, we were in the hotel, we'd go to the hotel bar, we'd have a beer, and they served bar snacks until midnight, I think. And we must have survived off baked potato skins for about 2 or 3 weeks on the trot.
Because this is what the bar people could just rustle up.
Yeah, that's all they could rustle up, yeah. And the bar, we'd go in there and the barman would see us and go, you all want, what do they call them, potato cheese?
You'd have them with, yes, I knew them, the sour cream ones, although those hot red sauce things, yeah. We knew them well, yeah.
That's what we existed off. That and the hearty breakfast. We had a lot of breakfast, didn't we?
Because this was the sort of ethos at the time. You basically just worked and worked until you pretty much dropped.
Yeah.
I mean, was that sustainable?
Probably not, but...
Was there a date being worked towards?
Yeah, it was launch.
So that launch date, the Lincoln Centre...
Yeah, well, that was...
They'd already set that date?
Pretty much. I mean, I can't remember when they actually set it, but they made a decision, and then they said it's got to be all working by this time. And
at this point, it wasn't all working.
Well, there was
getting close.
There were a lot of things they wanted to put on. I mean, one of the main things was that we hadn't actually made it, so the famous demonstrations worked under AmigaDOS.
So at the time, those demonstrations that they'd done at things like CES were all hitting the metal directly and weren't operating system friendly.
No, not at all. So they had to do quite a lot of work to make their demonstrations work inside a window inside AmigaDOS.
Because that was going to be one of the main things that they were going to be showing at
the famous the ballerina in particular. They couldn't really show that without it being part of the operating system.
So at this point, we've got, we're on the run up to the event, and we've got practically all working now, mostly.
Mostly working, yeah.
So I'm guessing this was one of the reasons why there weren't Kickstart ROMs at the time, because Tripos lives on disk and in the ROMs as well.
Well, the whole Kickstart thing wasn't just the Tripos side of it. It was all of our work, the whole of exec and
so all the drivers,
everything.
So you've got exec.
No, exec was loaded off. That literally, when it said Kickstart, it was a very, very dedicated small EEPROM that put up a picture of a disk and said, and had enough code in there to go, load this into memory.
So that would bring exec in, some drivers, and then...
The whole of Intuition, the whole thing.
So that decision to put it on disk was because they weren't ready to have it burnt into ROMs at that point?
EEPROMs were too expensive. Mm-hmm. And
so they need to use mask ROMs, I presume, to keep the cost down.
And mask ROMs are expensive to produce, and you don't want to throw a whole lot away because you have to make a lot of them. Yeah. So whilst they were only selling relatively small numbers, they made the decision to put it into this funny RAM which they could lock. even though they were losing money on each one they sold because the RAM was expensive, just to get basically beta test. I don't even call it beta test, but it was basically.
So on the early Amiga 1000s, then you've got not only the RAM that other Amigas would then later have, so your 256 kilobytes or your 512, but you'd also have another dedicated piece of RAM that they could lock.
Yeah, which was sort of hidden. You couldn't use it for anything else apart from, it was just where the ROM would have been.
So now we've got to the point where you've got an operating system, everything's all working mostly. They've set the date for the launch at the Lincoln Centre. They've got Andy Warhol involved. They've got.
Well, we didn't know who they had involved.
So at that point,
that was all a surprise.
You've got an invite then.
Yeah, we got an invite. But I mean, prior to that, there was a huge demand for us to get working systems out to developers. It was developers who were the important thing. So the reason they did all this stuff with the Kickstarter and all the rest of it wasn't to sell it to the general public. It was to make sure you could get computers to people like Electronic Arts so that they could demonstrate their games, which was going to be the heart of the Amiga offering.
Are they still these sort of rough and ready black box systems?
No, by this time they were the first production run, just like the one that you've got at the museum. Oh, no, the early one because it was NTSC, but they had the Kickstart and so on and so forth, and that was really the main target for these people. It was for developers.
So this is before the Lincoln Centre launch. So you've got these out under NDA to people like you said, like Electronic Arts. And was that to create some of the software that they were going to be demonstrating?
Oh yes, it was very important to have things like Deluxe Paint at launch. Hence Andy Warhol using it.
So those went out to the developers, so they're creating the code. So what sort of time were we talking between that and then the launch then?
When was the launch? 85?
Where somebody had a picture of there.
Oh right, yes.
Does that look familiar?
Very. I think I've still got one somewhere. Yep, black tie. It wasn't optional for us. We were all told that we had to wear black tie. But Commodore had arranged them all.
So we've got Tuesday, July 23rd, 1985.
1985, yeah, July 85, I think that'll be right.
So you're basically told black tie event at the Lincoln Centre, world premiere of the Amiga. So you know obviously what it's about, but you don't know anything else.
I didn't know where the Lincoln Centre was or what the Lincoln Centre was or anything. We just got flown over by Commodore and we all stayed in this hotel in New York.
And from what I've seen of the video, there's like a reception, cocktail reception. And then you're all led into the auditorium.
Big auditorium, yeah, and there's a lot more people there than I expected. I thought it was just being a press launch of, 100 people, but it must have been around thousands of people. Yeah.
And I think Bob
Pariseau.
He was the main presenter, wasn't he?
And he was the head of software development.
So he goes up on stage and they start introducing the machine and going through the software. I'm guessing with all this going on around you, you must have been.
I know because I wasn't part of the actual demonstration team, so I'd done my work. I was just watching back, enjoying having had a drink.
So you were quite happy. You were pretty confident that your part of the deal.
Yeah,
was
my part was going to be. Yeah. And they practiced it, obviously. The guys giving the presentations. But yeah, it was quite an interesting evening. And hey, I got to meet Debbie Harry too at the party afterwards.
I mean, what did you actually think of the show that they put on?
I thought it was an appalling waste of money. It was fun, we had a great time, but I mean, Commodore had like this marketing budget and this development budget, and obviously the marketing budget was significantly bigger than the development budget, because for a small percentage of what they paid to put on this amazing event at the Lincoln Centre, they could have hired another employee who actually wrote code.
I'm guessing, though, because the Amiga was so different in terms of the sound and the graphics capability, that it kind of needed that glitz and glamour to go around it? Because up until that point, most things have been quite boring, monochrome.
Absolutely right. But two issues. Firstly, I think probably the majority of the press didn't understand that the Amiga was doing all these sounds and making all these pictures. They really didn't realise that this little tiny computer could do all of these Hollywood-type events. And that was a really hard message to get over, because it was so radically different. And back to Commodore marketing, of course, they didn't understand it either. They really didn't understand the main points. Was it a games computer? Was it something that you sold to the Hollywood industry to make films with? I don't know. And of course it was both of those things.
So they were trying to find new markets for this.
Yeah, but they only really knew about the games market. And yes, it was a good games machine. It'd been written as a games machine, but some of these extras, like the video toaster, that meant that you could take live video and subtitle it and put things on it, so on and so forth, opened up whole new areas to it.
So we've had a successful launch. They've then gone on to create PAL as well as NTSC versions.
That was quite a lot later, yes.
You're still both at Metacomco.
Up until 86.
So well into the Amiga's launch, people have got them out there. And have you handed over the Amiga operating system at that point? Or are you still sort of bug fixing it, tweaking it?
No, we'd handed it over, but we had an ongoing contract to do a whole bunch of different improvements, make the disk system faster, make this more American, a whole bunch of things. I mean, Jessica was doing a lot of the documentation, and you had to change some of the words, didn't you, because they mean differently in American.
Yes, I had to write in American.
I mean, the biggest problem is default, okay? So we would say something like, by default, it uses the floppy disk. American doesn't understand what that means.
Well, they do, but it means something slightly different.
Well, to default in America is to not pay your bills. So you have to say something like, unless specified otherwise, it uses the floppy disk.
So in terms of our use of the word default hadn't quite come into their
No. And there were a bunch of other ones, obviously.
By that time, I'm guessing you're getting itchy feet at Metacomco. You want to do something else? Or are you happy there?
No, I wasn't. I think I'd done it. I had my big project, and I was being asked to sort of keep it going, hand over to some extent. There was a chap that used to come over quite regularly to Metacomco from Germany, Wolf, and my job was to tell Wolf how the filing system all worked, but it was complicated. I mean, going back to the guy who originally wrote it back in Cambridge, it was complicated. And so it wasn't just a question of saying an afternoon's training, it was he was with us for like a month, staying in the local pub.
So it's around improving it, maintenance, and passing the knowledge on.
Passing the knowledge on, yes, absolutely. And then, of course, there were things like they brought out the hard disk version, so there were a few improvements made when we finally had a hard disk version of it. And as the hardware evolved, the operating system needed tweaks as it went along.
So at this time, has the challenge gone out of it then?
Not really. I mean, I'm perfectly happy doing it, but I certainly thought I wanted to do something else. And so I decided to start another company, which was Perihelion.
So this is the first company you founded yourself?
Yeah.
And you founded that as a husband and wife team, or?
It was three of us, in fact. It was us two and my very good friend Jack Lang. Jack's very well known in Cambridge circles, and he's a classic entrepreneur. He's currently, I think, chairman of the board of the Raspberry Pi Foundation. I mean, he's still very important to computers.
So was he the one that was almost suggesting to you then?
He financially backed us. Well, I mean, first of all, I knew the company would make money, Perihelion, as soon as we started it, because I had a contract. The contract from Amiga went with me.
So that was the contract to do what?
To look after the Amiga and maintain it and so on.
So how come that didn't stay with Metacomco?
Well, I chose the month it expired to leave and tell Amiga and all my friends in Amiga that I'd left.
And they then went with the knowledge rather than stick with the company.
And of course, Commodore by that time owned the IPR to the program, so I was merely maintaining Commodore's program. It wasn't I'd stolen the program from Metacomco because they'd sold it to Commodore.
Then, as well as doing that, what were Perihelion?
Well, the big idea with Perihelion was that we were very interested in this new chip called the Transputer, which is made in Bristol. So we thought it probably needs an operating system. So when I started Perihelion, we took with us originally one, but eventually three. Nick.
Yes.
He could be my research assistant at Bath University.
Yes, the core team.
Yeah, the core team came with me.
What was special about the Transputer then?
The whole idea there was this new architecture. I tend to get involved in these projects that are way ahead of their time. The idea with the Transputer that you had lots of them. Okay, so it wasn't the idea that you had one processor, you had like 1024 of them. And when given a job, they could pass it among themselves and perform it in parallel. Now, parallel computing has long been a holy grail of computer science, but there's lots of challenges in doing it, and that's why it's still a problem these days. I mean, these days you can have a 4 or even 8 core Intel processor, but quite often there's only one core doing any work. You've really got to go to a lot of effort to actually make all the processors work. And even if you, a classic thing in compiling a big program, you type make, and that means go ahead and compile and make a program. And you can go, an option to it, you can go make -J 16, for example, and that says go ahead and make it, but use 16 concurrent processes all at the same time. You've got to make sure that this thing isn't waiting for this one to finish before it can carry on, so it's got to have like 16 independent threads. But as an indication of parallelism, at one point I was creating my own versions of Android, you sort of roll your own versions of Android. And I bought this big Xeon computer, but even so, when I went make Android, it was like 23 hours. It's a big job. But if I eventually got SSD memory on the disk and put in a 16 processor core and went make -32 or something, I got it down to 25 minutes, which is really impressive, being it's the same bit of hardware. It's just the way the software's programmed.
So rather than just having one core going...
They're all flat out. And what's interesting is you go make -32 or whatever it is, and suddenly all the fans come on and the whole thing gets red hot, but it's obviously working. So anyway, back to transputers, that was the idea. You'd have parallel processing. So every transputer had its own memory, its own processor, and 4 connections, so it talked to other things.
So it was like a processor network.
Yeah, exactly right. And so we started working on this operating system called Helios, which was aimed to be a bit like Unix, but could run processes in any process or whatever it liked. And that was very interesting. And you had specialists of these little nodes. So you had a specialist node that had graphics memory into it, so you could make a graphics screen. You had another specialist one that had a disk talking to it, and so on and so forth. It never went anywhere, really. Inmos, really, again, didn't have the money to create it. And so there was like an early version of the transputer and then a middle version, but the next version never came out. It was famously called slideware, in the sense that the actual computer, the actual hardware, never actually existed. It was just a set of PowerPoint slides telling you what it would do. And so that didn't really go anywhere. But it was a fun period.
So the Helios operating system, because the processor didn't take off, was there much market for it?
Not really, but we did make a version for the ARM eventually. I can't remember what for, but we did. But that didn't make a huge amount of money. So apparently it sort of fizzled out in the end with
10 years.
Well,
10 years.
Well, 10 years, but we ended up selling a whole lot of services to an American guy who sent us a $100,000 check that bounced.
How did that get resolved?
The company went bankrupt.
Right. Fair enough. So Perihelion sort of starting to run down. You've got new ideas?
I've got new ideas. So I leave Jessica holding the baby at Perihelion. So she becomes managing director of Perihelion.
Next, yeah.
And I think what's interesting next is the internet. So I went out to America and I saw I went to America and saw America Online, AOL, and saw what they were doing.
What year are we talking here?
When I was 40, so that's 1994.
Right.
And so I said to my friend Herman Hauser, Herman's quite an important thing in my life. He's a guy who started Acorn Computers with Chris Curry, and he made some very, very savvy investments, so he's a very wealthy man. And he invests a lot back in. Anyway, he invested in what I started, which was UK Online, but only a relatively small investment alongside my own investment. But he said, you need to phone this man called El Sereno Piol. No other guide about who it is, but I look up the international telephone number and work out it's in Ivrea in Italy. And I know enough about Ivrea as it's the headquarters of Olivetti. So I look up Olivetti, and remember, there's no internet in these days, we're just inventing it.
So at this point, had Olivetti bought Acorn? Because that was around that time.
Yes,
right.
Before that, Olivetti had bought Acorn, and Herman had been head of Olivetti Research, so he knew Olivetti very well. So anyway, so he says, go and see PL. So I go to Turin Airport, and a car picks me up from Turin Airport and drives me all the way up to Ivrea. And I sit and wait and see one of Mr. Piol's secretaries leave. He has two secretaries, one for the first half of the day and one for the second half of the day. And eventually he's just coming in and he's sitting there with a big cigar. He says, you've been recommended by, I can't do the Italian accent, but basically you've been recommended by Herman. You have this idea to do this internet. We already have an investment in something called Italia Online, so you could take some ideas from that. And I thought, yeah, that's a good idea. And so he says, so you want to make something called UK Online? And I say, yes. And he says, so how much money do you want? And I say, £2 million. And he says, okay. That was it.
Easy. And UK Online was born, and selling well.
Yeah.
Well enough to have somebody else knock on your door and say, we would like to buy you.
Yeah, that was a bit later, but going back 3 or 4 years, I suppose.
So basically, UK Online's growing and got to the point where...
Remember, it was very early days. We did a deal with Currys where we paid them a large sum of money, and they agreed to put CDs that we'd made into their stores. Because at the time, the operating system, remember this is Windows 95, didn't ship with TCP/IP, let alone a browser. So our CD had to contain a third-party TCP stack and a browser. That all began to change quite quickly, but we had this very early browser, I can't remember who made it now. But then eventually we were able to do a deal with Microsoft, when Microsoft finally brought out I can't remember who it was, but in the early days we really had to provide everything. It was literally the whole
I think it was around 94, 95 that Microsoft finally took the internet serious with Internet Explorer, wasn't it?
And it was a bit late. Yeah, it was a bit late. Anyway, this was this early gap in between, so we had to do all of that. But then, yes, we sold out to a company called EasyNet, who at the time just had a commercial arm, and they only really bought us for one reason. When I'd set up UK Online, when you used the modem and it went feeble, and then you had to say who you were. I'd set it up so that it checked with the accounting department to see whether they'd paid their bill, and if they hadn't paid their bill, then it would stop working, and they'd phone us up and say your system isn't working, and we say to them that's because you haven't paid your bill. So he kept very good credit control, and at the time, EasyNet had a very poor credit control system. They had lots of people who had it for nothing because they couldn't keep track of who they'd given it to.
So here you had ready to go.
So that worked quite well. And they kept UK Online separate for some time, and then eventually I think they merged in. And then quite a short time later, EasyNet were bought by Sky, and that was actually the heart of what is now Sky Broadband.
Oh, right.
So it still lives on.
It all back to there. So you've sold EasyNet, and Perihelion by this time, is that still going?
No, Perihelion.
That's now closed.
Yeah.
Now what? What's the next challenge?
The next challenge was we both got sick and tired of employing people. So I decided I would just work for myself as a consultant.
So you've got these huge amounts of experience behind you, and now you're going into other companies, other startups.
Well, what actually happened was I can't remember how I got to know, but I got to know a very large company called Computer Science Corporation, CSC. And they contacted me, I think, and said, we don't understand about this internet thing, but we think we're going to need to. It was about 1996.
Yes.
We don't know much about it. Will you come and advise us, come and advise our customers? So I ended up having a business card with then my name on their company, but I never worked for them. I remember very clearly sitting in my house in Frome, writing this letter which was saying, basically, I'll come and work for you. And I'd left blank the amount of money I'd charge per day. And I tried putting in one particular figure and thought, right. Tried another figure and thought, I talked to Jessica, I said, what number should I put here? And in the end, we decided, go for it. They can only say no, and I put a particular number in. And I sent this off, and I got a reply back immediately saying, yes, that's fine. And I realised I'd pitched much too low.
We thought it was ridiculous. Big number, double it.
So that was very good fun, actually. I had great fun. I advised Nokia. I've got a little ball somewhere showing a Nokia away day with CSC and BP, I think it was. I wrote a business plan for somewhere in what was that place in Amsterdam? I can't remember what that was, but...
So these are huge companies.
Yeah, because CSC is a huge company.
And they're all trying to get to grips with this new internet thing.
Yeah. So it was really quite a boom time if you know anything about the internet, because it was coming like a wave, but most of these big companies had no idea what it was. And even now you've got companies...
So it was this tidal wave heading towards them, they didn't know what it was, and you were there to throw them the life jacket.
And, well, not only that, just actually to explain, they were coming from a totally different perspective. But anyway, that's what I did. And then I started to merge on again through my friend Herman Hauser. I started to advise. I worked with his venture capital company, AmigaDOS Capital Partners, and I would go and investigate companies who were seeking money and see whether it was a good idea technically, which again was very interesting. I had to sign an NDA about what they were doing, but traditionally, a venture capitalist would send out a lawyer to check the legality of all the agreements, an accountant to check the books, but they didn't really send anybody out to check the technology. And after a bit, when the technology was getting harder and harder, it became more and more apparent. And I know I went to see a particular company for a particular venture capital, not AmigaDOS, and I noticed that they had this very nice idea, but they were running it on a database called Access, which is Microsoft's desktop product, and they want to scale it from 100 things to 10,000 things. And you're not going to run 10,000 customers off a small PC running Access. So they needed to put in a proper database like Oracle or something like that. And I know later that reduced the value of the company from £10 million to £1 million. So I saved this particular venture capitalist £9 million. My job was to give the CTO a hard time. And there were some times, famously, when I went in and the CTO was too busy to see me, and they never got an investment. If your chief financial officer is happy to see the accountants and your CEO is happy to see the legal guys, why can't the CTO see me?
So you've been going into companies, advising, using your huge wealth of knowledge, and is that what you're still doing today?
No, I'm retired pretty much now. I haven't done any of that for probably 3, 4, 5 years. I've got more slightly obsessed with providing internet in rural areas. So I live in a rural area, and I've set up this little company with a mate, and we have very small, 150 customers, but who couldn't get internet otherwise, and they can through these radio systems that we put up.
So this is basically catering to the people who the big providers just ignore.
But it's never going to be cost effective. Never. Basically, we use a radio system to take a service from people who can get it to people who can't get it. Simple as that.
I think now is a great time, if I may, to go through some questions that some followers of mine on YouTube and Twitter who are very much still into the Amiga all this time later. And one person in particular, I know she's been using Amigas for a lot longer than I ever did in terms of, in about 95 I jumped over to a PC, but there were people who were using their Amigas for well past then, sometimes even into the early 2000s, and then in recent years it's all made a huge resurgence again. Right, so I'm going to start off with Vicky's questions. Metacomco shell, a product marketed in early Amiga days, is this what became Newcon in 1.3?
Probably.
Is this well after you'd gone?
The shell was simply the basic thing to give you a CLI prompt and let you type in a command name and so on. And it was an integral part of Tripos. And I believe they rewrote it. It was very BCPL oriented, so when they started making a more C version of it, the whole point about the Tripos shell was that it had a completely standardized call to the BCPL library, which printed out all of the arguments it was expecting. So you could go to any command and type whatever the name of the command was, question mark, and it would just say, I'm expecting this with a keyword, I'm expecting this, which you have to leave it, and this, which is optional, and so on.
Tell you all the parameters.
All the parameters better. So it was a really nice unified way of asking for all the parameters. And in fact, it was the invention of one of the PhD students who was working on the early tripods. It was there right at the beginning. So they had to come up with something else for a later version when they started converting Draw to C.
And were there other features that you wanted to integrate but Commodore refused post-Amiga launch, meaning that something like Metacomco Shell was needed?
I don't think Metacomco produced a separate product called Shell. I think it may have just been a sort of side effect of some of the languages they produced. No, Metacomco was just doing these languages and had this focus on the languages. I was just doing what I was told, really. I mean, you know, the guys at Amiga said we wanted to do this, or it doesn't do this fast enough, and I go away and go, okay.
So your work with Commodore at that time was on the version 1 point something.
Yeah.
And that kind of leads nicely into Vicky's next question, which is, did you have much involvement in moving AmigaDOS away from BCPL to C in DOS Library 2.0?
Yeah.
So that was that all Commodore?
Yeah.
Okay. So by that time, that's when pretty much your involvement with the Amiga.
Well, they wanted to move on and have it under their own control. They didn't like having it all. You know, nobody there understood BCPL or anything, so they quite reasonably had to invest a lot of effort into basically rewriting everything. But you know, the machine was selling by this time and so on and so forth, so they had the luxury of time.
Now, this next question is from a gentleman called Pete, and there's recently a thing called the Mini Amiga coming out. And what he wants to know is, what do you think of these Mini Amigas? Of somebody making and marketing a mini version of something you had a hand in decades ago must be a strange feeling.
It is very strange. I mean, I can sort of understand it because there was this whole swathe of people who used the Amiga for gaming. And I can see that it's very attractive to have a little computer that runs those, you know, traditional games that you saw. And the games I saw were all very clever. Marble Madness was very clever. I liked the Battle Chess, which I still think Harry Potter ripped off in the films. And but I was never a games player myself. I mean, I was too busy doing all the other stuff. So it was all the other people who played all the games and so on and so forth. But I was surprised by how it took off onto the video overlay side, really, and you know, how large Hollywood studios thought Amigas were useful things to use. And so there was a whole range of it being a sort of video editing tool that nobody really had considered. It was just about, by chance, not chance, it had been designed with this feature called GenLock, which allowed to lock onto the video stream. And suddenly a lot of people could make hardware add-ons, famously the video toaster, that suddenly opened up to a whole sort of new range of things you could do with this.
Tomas would like to know, how much different would AmigaDOS be if there was an MMU on all 68,000 chips?
It wouldn't have used Tripos, and it wouldn't have used exec. I mean, the whole point about exec, and the other operating systems of the time, Tripos and any of the other ones, was that it didn't pass messages, it passed pointers to messages, which by definition meant that one process can read another process, which has a huge flaw, which is if you have a program that goes rogue, it wipes out everybody's memory and makes the disk system go corrupt and all sorts of things, which happened quite a lot. I got blamed for it, but not my fault, Gov, you were writing over my memory. No, if it had an 020, with a proper memory management unit and so on and so forth, you would have gone for Unix. That would have made it suitable for Linux coming along later, but at the time it was Unix, because that was what Unix expected, because it had been written for that.
So you think Commodore probably would have even gone with a completely different operating system rather than even make their own?
Well, the chip would have been a lot more expensive, and the associated bits with it would have been a lot more expensive. It would have needed a hard disk, so you can't really do virtual memory onto a floppy disk. Yeah.
So really what we're talking about then is the fact that Motorola had brought out this chip, leaving out those concepts that were available at the time. To keep the cost down. It was
about cost, but it was also about, I think, Motorola's perceived slot in the marketplace for the chip. It wasn't trying to, I don't think it was trying to compete with the custom silicon inside PDP-11s and those sort of machines. It was like a level up, which were by definition multi-user computers. That's really why you need the memory protection. So one user can't write a program that crashes the session of another user. The Amiga was obviously never a multi-user computer, although in theory it could have been. If you put a serial port on the back, it could have had another CLI running on it. But it wasn't part of the original design, it wasn't part of the design of Tripos or Exec, and they would have probably used Unix or whatever it was, although at the time the licensing of Unix was incredibly complicated because various companies had claimed ownership to bits of Unix. So when Linus came out, it all got cleared up.
So really, Tripos and the 68000 was sort of like a marriage made in heaven.
Absolutely.
Doug of the 10-minute Amiga Retrocast would like to know what were the realistic expectations of multitasking with 256 or 512 kilobytes? And he goes on to say, what did you expect people to be able to do back in 1985, and what surprised you the most about the direction the Amiga took? Now, I think you've probably touched on a couple of things.
I've touched on the direction where the Amiga took, and that was really all the video stuff and so on and so forth. Nobody really intended the multitasking nature of things to be fundamental. There's too little memory to be able to do the classic things we did as a demonstration, which is to compile a program whilst editing a program. Yeah, nobody really did that. But there's lots of really useful features, in particular the fact that the filing system is working behind you. So you go, even now on an Amiga with floppies, you go copy A to B, and you get the prompt back pretty damn quickly. And in the background, you hear the disks go ka-chunk as they actually finish off doing all the copying.
Now, Chris has an interesting question, and I think this is probably more a workbench thing if I think back to my time on Amigas. How do you feel when people call them folders or directories instead of literally what it says on the icon, which I presume he's talking about drawers? Am I right there?
Yeah, there was a lot of contention on these names, actually. Tripos called them directories.
Yes, that dated back from Cambridge days.
Yeah, and that was because the Phoenix operating system for the IBM 370, you had directories. And directories contained files. That was how it worked. So Tripos took that over, and in fact, in the original Tripos, the symbol for between directories was a dot. So you might have A dot B, and it didn't mean A of the file type of B, it meant A directory and there's a file called B inside it. So that's one of the very early changes. I had to put slashes instead of the dots, and to allow the dots not to be that character and all that sort of stuff. And then the Macintosh had started calling them folders. So that influence came on and called them folders. But then the people who did the icon design, there was two people who were full-time graphic designer, called them drawers.
And then obviously created the pictures like drawers. I guess at that time, I think there's a term for it, skeuomorphic. It's about sort of relating what the computer was doing to real life things like folders and drawers and stuff.
And obviously back in England, we wouldn't have used the term drawers.
No. Poly P2000, what features did you have to drop, ... because of management decisions?
None, actually. None.
Pretty much what you had in a Tripos, the things you wanted to implement were all in there.
Well,
it cut down, but
we cut down a bit, but the visual editor got in there.
Yeah. Was this a time thing or a memory?
It's just that they were just there. I remember having a small battle. I'd written a very simple screen editor that lets you edit things, and that everybody was familiar with that, and then it was called Ed, and everybody liked it. It was fine. But earlier, Tripos came with a version of the editor back in Cambridge University and on the IBM mainframe, and that was called Z. And there was a version that came on Tripos called Edit, and it was a line-by-line editor. Okay, so you go, move to line 15, M15, then you type something like C/B/C, and that said change the first B to C. Very cumbersome in many respects, and you really would want to edit a lot of things with it. So they all said, well, let's chuck this out. And I said, no, you're missing a point. This is really useful for programmatic edits, because you can make it run off a file which contains all these move to 15 and change this and so on and so forth. And that's the reason in Unix that you've still got sed, which is exactly the same thing, basically. It's a stream editor, but it's extremely useful to, over and over again, change a file in this format to a child into that format. But I won that battle, so it was in it.
Now, the Southwest Amiga Group Twitter account, which I'm pretty certain this is you, Dave, putting this one in, which is very much a chicken and the egg. Which came first, Workbench or the prompt?
Oh, well, the prompt.
So your Tripos came in.
By 5 years. I mean, because Tripos on the early Data General machines, that's all it had, a prompt. You know, you plugged in a VDU, as it was called.
So you're basically saying you were here first because even before the Amiga came out, you had Tripos.
And the command prompt. And this whole namby-pamby new idea of putting graphics on the screen, was much later, basically.
So when you took Tripos to Commodore, I presume they had people working on Workbench at the time?
Not really Workbench, no. They were just working on Intuition, and Workbench was built on top of Intuition.
Right.
And you couldn't really do anything on Workbench until you had the disk operating system underneath it that did it.
No. Okay, so naturally that had to come later. Now, I kind of understand, I think, what Dale's asking here, because he cheekily asks, why couldn't you allow del instead of delete, and also cd dot and cd dot dot? So I presume this is all around shortcuts in typing commands.
Yeah, there was a lot of discussion about whether we should make it exactly the same as Linux, or Unix at the time, or not. Tripos already had some of its own slightly quirky ways of doing things, and we didn't want to slavishly copy the whole of Unix, because there were a whole lot of things that we couldn't do because the whole file structure is different and all sorts of other things are different. So things like Unix has got symbolic links, which is where you think you're using a file but actually it points to another file, and Tripos never had that. And if you don't have that fundamental thing, then there's lots of other commands that come around it that you can't work with that thing. So when it comes to, I think, things like dot and things, I think that's just something we just didn't bother to put in, but we could have. What was the other thing that he said he missed?
Putting del instead of delete.
I can't remember, did we actually call it delete or del or whatever?
That's a good point. I'm pretty certain it's probably the whole word delete.
Okay, well the answer to this actually is very simple, because the way of Tripos works is that you can simply rename the command, which will be in C:delete, and call it C:_rm if you want to type rm to delete files, or del if you want to type del to delete.
Or I guess you could just have a copy of it and call them the same file, because they're all basically, like you were saying earlier, they're pointers to the
files. So you could make it yourself.
You missed a trick there, Dale. And lastly, there's a gentleman called Ian, who's also known as DJ Hoffman, and he's, to this very day, he's created and he does a great DJ set using 2 Amigas, and he's also converting games from other systems to the Amiga, so he's very much in there at the machine code level and trying to make it operating system friendly and everything. He would simply like to say thank you. And thank you from myself as well. And of course, thank you for your very kind donation to the Museum of Computing. I'm looking forward to refurbishing that machine, making it a part of our collection. We haven't got an Amiga 1000 at all in the collection there. So I'm looking forward to getting that looking lovely, hopefully working, on display, and including your words with it. Thank you very much, both of you.
No problems.
I'd love to come and see it.